Yeah, vaulted. You know what else is gone? Factory. Like, you know where Despego was, and there was all the factories in between Despego and retail. They're all freaking gone. The freaking
Alright, I didn't give you any time for these, but we're gonna do them anyways. I assume US coins that are 55 cents. One is not a nickel. What coins are they?
The other one is.
50-cent piece and a nickel.
Because the other one is.
One is not a nickel, but the other one is. There's a
I got it.
for all of these.
I got it.
3 large people try to crowd under a small umbrella, but nobody gets wet. How is this possible?
It's not raining.
It's not raining. Take 2 apples from 3 apples. How many do you have? You have 2 apples. You took 2. So you have 2.
Oh my god.
The other person was left with 1 apple.
Oh
right?
my
But you
god.
took 2.
It's hurting my
Oh,
brain.
look at you can see the mind blown emoji like floating off from him.
Some months have 30 days, some months have 31 days. How many months have 28 days?
All of them.
All of them.
All of
have
them.
28
Nailed
days.
it.
I got that one.
Right. Plus more. Horse is tied to a 30-foot rope. A haystack lies 40 feet away, but the horse is able to eat it. How's that possible? Right, the other side of the rope's not tied to anything, right? The horse can still go wherever they want to
Oh
go.
my god. Hurting my brain.
They generally won't.
Technically, it could be tied like 10 feet away from the haystack, and then the horse is another 30 feet on it. But I like it now. You guys ready to do some recycling today?
Yeah.
Yeah.
What number are we on?
22.
We're on lecture 22 of 24. Oh, that's crazy.
Delete.
Lecture 22 of
Destruct.
24.
Pointer wrap up.
Alright, so that's what we're gonna do.
These are the lines that we told
That's what we're
about.
gonna do.
Come on.
Okay, you guys ready?
Sure.
Right? In recycling memory, we're also going to review how to create all the dynamic stuff we learned. Because we create them with new. Right, today we're going to learn how to give the memory back with the word delete. Right, so we're going to create them with new, delete them with delete. We can do that, we'll be good.
It's like me.
So we have the word new, create memory from where? Where does it get allocated from? The heap, right?
Yeah.
And so delete deallocates the memory and it puts the memory back into the heap. New takes memory out, delete puts memory back in. Good? We have that, right? So it eliminates the dynamic variable, okay? Not the pointer, but what the pointer is
Pointing to.
right? So it deletes the dynamic variable, returns that memory back to the heap, that way something else can use it. Right? Let's look at this awesome example. Right? Int star p, what did I create?
A box that
memory
points
address.
to something.
A box that can point to something. And what can it point to?
An integer.
An integer, because it's an int star. Right? Right now it points to garbage.
True.
Right? When I say p gets assigned a new int says create me a new integer whose name is what?
New.
Nothing. I was tricky.
Yeah,
I was
sorry.
tricky. There's no name. It has no name right now.
Right.
But a new int creates me a nameless box. But it also returns the memory address of where that box is. Right? From the heap. Right? And so p, right, points to it. Because we stored it, right? New int gets assigned. If you don't want to assign new int to anything, then you just create a box nowhere with no name and you can't do anything with it.
And takes up space.
Just take up space, which is bad.
Taking up 4 bytes.
You just say new int and you don't do anything else. There's not enough point to do it. You can't destroy it.
And you can have something else point to that as well, right?
Sure. We're gonna do that in a minute. We're gonna do it today.
Oh, cool.
Yeah. To get values in there, you do things like this, right? Star p equals 42. Right? Put 42 into the variable pointed to by p. Right? Put 42 in. Are we good with that?
Yep.
Okay. We talked about in last class that dynamic variables don't follow normal scope rules. So the memory will hang out for the whole program unless you delete it, right? So delete it, we call delete on the pointer. Okay, but don't be confused. I am not deleting the pointer. I am deleting what the pointer is
Pointing to.
pointing to.
You have a missed opportunity here to play like a delete scene from anime Death Note.
Oh my god. I don't think it's a missed opportunity. It's just a possible opportunity.
I mean, you were on a roll with the Monty Python, so it would have been awesome.
So delete P, delete what P is pointing to. So in essence, that box goes away. Agreed?
Yeah.
Everyone notice that my arrow's still chilling?
Oh.
Yeah.
Right? Because it's still pointing to that memory location, but I said that memory no longer is being used in my program.
So that pointing isn't,
Yeah, it's just garbage.
the pointing isn't a one-time thing. It's like a constant string that like sending back where that is. So now that
Right, because if you
it won't
think about
retain
it,
anything anymore.
right, what the arrow really is a memory address, right? So if this box was located at 0x3,
Right.
right, really what this pointer holds is 0x3,
Okay.
right?
Right.
Now when I delete this, right, the box still holds the memory address of 0x3. But I literally just told C++ that I don't want that anymore, right? So now it's pointing out to garbage, right? Where it used to be, but it's nowhere anymore.
Okay.
It's not actually deleting the box. It's deleting what's in the box.
It's deallocating, saying that location and memory can now be used for something.
I was concerned about what happens to the value when that box gets deleted, but you
It's still
answered.
there.
Yeah.
The value is technically still there until it gets overwritten by something.
So that P star or star P will still have
Theoretically.
42 in it.
Theoretically, it will
Theoretically. Okay.
Right, if you did it right in succession, it probably would be fine. If you waited just a little bit of time and did it again, then maybe you've already been allocated.
Okay.
Everyone good? What did I do? I created a dynamic variable and then I deleted it. Wow. Right? I didn't do anything in between. What a waste. What a waste. I had to do that in the last case.
Did I hear someone actually try to imitate the sound of a bunkalessa over there?
Air horn.
I don't even know what you're talking about. So as far as my pop culture ends like in the early 2000s.
I just did an air horn for an awesome joke, so.
Oh,
That's
it's supposed to be. Oh, I thought it was a
All right. We allocate dynamic variables with new and we delete them with delete. Good?
Yep.
Right? I'm going to say this a bunch today. Every call to new, so every time you say new, you need a corresponding call to what?
Delete.
Delete. So if you call new 5 times, you should call delete 5 times. And hopefully do it correctly. Okay? We also create dynamic arrays. Agreed?
Yep.
Right? So if I create a dynamic array using new, then I delete it with delete. But because it's an array, I'm going to add square brackets because when you work with arrays, we always just sneak in square brackets all over. So you put square brackets on the delete. All right, so let's look at this example. All right, int star a, yay! What did I create?
A pointer that points to something that's
A pointer
nothing.
that can point
To an
what?
integer.
An integer, or technically an integer array, right? Because it doesn't differentiate. A gets assigned new int 5. Well, new int 5 says create me an array of size what?
5.
Right? Whose base type is int? Return the memory address of where it begins. So in essence, 8 points to that. Alright. Good so far? Once you create a regular array or a dynamic array, you treat it like a regular array, right? So I can add values in there. Right? I think that you can do that now. Alright, so on so forth.
So if we wanted this to be an array of arrays, we would have had to do int star star a, and then a equals new star int,
Star.
and then that would be
you
int
do
star.
that.
Okay.
Which we're gonna do in a second.
Oh, sick.
Okay, so how do I delete things? You delete the pointer, right? Deleting the pointer deletes what it's pointing to. At works too. Right? But notice what's on my delete?
Brackets.
Brackets. And that says delete the array that A is pointing.
Oh, maybe you didn't have the
That's scary. Well, okay, everyone just imagine that I deleted it, right? I don't want to erase and then redraw. Good? All right, so the question was, what if I do this, right? No square brackets? Well, this says delete the array that A is pointing to, and this says delete the variable that A is pointing to. Which is just the very first element, right? Because the first element is one integer. So I say delete A, what goes away is the 4, right? But then other problems, right? What are the rest of the problems?
Did you shrink the array by doing that? Okay.
Arrays are always in contiguous memory, they don't shrink, they don't
Well,
change.
since an array only remembers the first element, your pointer's pointing to garbage.
Correct. Which means the rest of the memory's been orphaned, right? It's
Right.
hanging out. Right? For the life of the program, right? The memory leak. Right? So is that good or bad?
No. Awful.
Awful, right? So put what on it?
Brackets.
Yeah, without, right? A points to garbage and everything else is just hidden somewhere else. Exactly.
So the female tries to access
It should theoretically still be able to find it. But it probably won't say. Working with memory after you screw things up normally causes errors. But not guaranteed. Which is why they're so frustrating. Alright, so we created a dynamic variable, we deleted it, right? We created a dynamic array and we deleted it. What's the other dynamic thing we know how to create?
Arrays of arrays, or objects.
Well, okay, objects, right? But objects are really just what?
Arrays of arrays.
Variables, right? So you just create them like you would create a variable and then you delete it. So, I'm not going to do that example. I already did it, right? So last thing we have is our, right, two-dimensional array, right? Could be more, but we're working with our two-dimensional.
Oh, so I was right the first time.
Yeah.
Nailed it.
Right, remember, right, two-dimensional array, as Chris is like saying today, is an array of
Arrays.
arrays. Right? So let's remind ourselves what that looks like.
Basically, the
Right, so let's imagine I have some A, right, which is of type int star star, right, which points to an array of int stars, which points to arrays of what?
int.
Good so far? Right? I can screw this up, deletion, right, a lot of different ways. Now think about, how did I create this? Well, I said int star star A equals new int star 2. Right?
Right.
And then I looped, well, those stars are terrible. Right? Int I equals 0, I less than 2, I plus plus. Right, and then I said A at I equals new integer array of columns.
And that's how you made the.
That's how I made it.
The second part of the array
Yes.
of arrays.
This top thing created this, right? Now this looped through it and assigned these to this.
So with that, you're never really wanting to create the second dimension without accessing it, and that's why you write it in a for loop. Okay.
And I'm gonna, because I want to access all this once. How many times did I call new?
Twice.
Not
Well,
really.
technically you called it however many times because of the loop
I already had that loop,
iterations.
right? So technically I called new 3 times.
Yeah.
Right? Agreed? Which means how many times do I need to call delete?
3.
3 times. Yeah, at least it matches. It's not like off by 1. So, right? If I want to delete what I created, what should I delete first?
From the most, for the least stars to the most stars.
Least stars to the most stars, right? You always leave the most starry person to the last, right? Right, but think about it, you have to delete these because the only way you can get in is via A, right? A goes to here, goes to here.
Mm-hmm.
If you delete the middleman, then what happens? You can't get to these, right? So you have to delete these first. Now these were created in a what loop?
For loop.
For loop, which means they probably need to be deleted in a
For loop.
and that needs to happen first or second? First, right? And then after I delete those, then what can I delete?
The star.
The star. So you do it in the reverse order, right? You always delete in the reverse order of how you created. That way you get it correct.
I guess you could. It's easy to remember that because the thing's always pointing to one less
Right.
star, so you would delete one more star.
So So let's talk about this loop. I equals 0, I less than right size rows 2, I plus plus. I'm going to delete square bracket, right? Because these elements are pointing to arrays. Agreed? Without square brackets, it would just delete the first element, which would be a problem. Right? So I delete square bracket A at I. Well, if I is 0, A at 0, which is a pointer, we're going to delete the array that it's pointing to. Right? Which deletes what?
That entire.
This entire array here. Right? Then loop iteration ends, I increment, so now I'm here, I delete A at 1, square brackets, right?
Yep.
And it deletes this.
So when you're deleting, you're never putting a value in the brackets. Okay.
Would you need to do it the other way around so that you the second elements within
The order, this order doesn't matter. Because you have the array that's pointing, so whether you start at the top and go down and the bottom and go up, it doesn't matter. They're each their own array. So order there does not matter.
I think what you're
Because I
thinking
said
is.
the opposite, right? But technically, right, my middle array points to where it needs to go, so as long as I go to every spot, whether top, bottom, or top.
Boy, I think what's happening is that array that's getting pointed to originally, that one's not actually having anything happen to it, it's the ones inside that.
That is happening to this array.
So you can still go, the order is okay, because I think that's what you were asking. Okay.
Okay, and once, right, so I went through, I deleted this, and then I deleted this. Good?
Yeah.
Loop ends, right, and now what do I need to delete?
In star.
Right, this guy. Alright, and so to delete this, I have to delete the pointer that's pointing to it. So I delete what?
Star,
A.
star.
So not delete A, but delete bracket. Right, which gets rid of what?
Both of them. Oh, that.
Right? And then A is just left. There you go. Hanging out. Make sense? Right? You guys are smart. What happens? Right, let's redraw it. What happens if I just say delete square bracket A? Does that delete my entire multidimensional array?
No.
No.
No. It deletes the array that A is pointing to. And the array that A is pointing to is this array.
The size 2.
And what's left over?
The second dimension.
Right, the second dimension, right? However many were there, right? Which is kind of the bigger spot too, right? The ones that are taking up the most room. So don't do that. That one's really bad. Agreed? Make sense? So we can now create and delete dynamic variables and objects. We can create and delete dynamic arrays, and we can create and delete dynamic multidimensional.
So we would need to call delete for that for loop you wrote over there on the board. We need to call delete square brackets
Yes.
3 times. But a 4th time if we
If I
wanted.
call new and I use square brackets,
Right.
then I'm going to call delete with square brackets.
Right. But then to delete the in star A itself, like the A is floating there, you wouldn't use brackets. You would just delete that.
So you say delete, you would still say delete square bracket.
Okay, and that would
Because
delete.
they're both arrays. They both
Right.
got created with square bracket.
Okay.
So you delete it with square bracket. This thing here, right? This garbage here, right? We call them dangling pointers because they're just left, right? Hanging out. Right? So good idea is to have that then set to null. Right? Remember null is like 0 for pointers. When I set it to null, that way it's not, right? It's not pointing out to garbage, it is null. And then you can check it for null. The newest compilers use something called null pointer. But for us, we'll just use null. So let's look at this example. Alright. Alright. Like, what were all those words? I don't know.
I don't know.
We're back. Alright. How many pointers did I create?
2.
2.
Dos.
Just remember there's a typo on this one. I'm gonna fix that.
Yeah, P1.
Yeah.
God forbid you miss something and you put it before.
But I should have fixed it because last class I knew that it was there. Exactly. P gets assigned a new int, right? Which says create me a new int, right? And point P to it. That's really what that's saying. You say P equals new int. It says point the pointer to this new nameless variable. Right? And then P2 gets assigned P. That's assignment of memory addresses, right? Assignment of pointers.
So it's saying point to the thing that that's pointing to?
Is that really what it's saying, or is it saying point to P, which is pointing?
Well, let's see. P holds this arrow, right? But probably for you it would be helpful to realize that it really holds like 0x1. Okay? So we say P, which holds 0x1, right? 0x1 gets assigned to P2. Right? And so P2 gets 0x1 as well as a value. Right? They both store the same number, which means they both point to the same. I know we want to say, oh, that points P2 to P, right? That's our natural approach. Now, if I delete P, that says delete the variable that P is pointing to. Right? Everyone good that this goes away?
Yep.
Right. How many dangling pointers do I have now?
2.
2, right?
Whoops.
Guess who keeps track of the dangling pointers? You do. Not me. You do. Right? You're the programmer. C++ is one of the programming languages that gives you the ability to deal with memory that you have control over. But you have the control, which means that you have to deal with it.
It can be abused.
So you have to remember that your two things are pointing to the same place, but you just deleted one of them. Right? Can I say delete P2 now?
Yeah.
What part gonna happen? Maybe crash my program? Right? Because is P2 really pointing to anything? No, right?
Oh, you're saying now.
Now,
Okay.
after.
I'm sorry.
But P equals null, does that work? No. Right? Which really is actually, instead of memory address 0x1, it's memory address 0x0.
Mhm.
And then I could say things like, yes, at this point, P2 is still pointing to 0x1.
Because it's not going to go back to P2 was.
Yes, exactly. They're not linked. Right? So P2 also has to be set.
So
That make sense?
Or could we just now say P2 equals P?
You could do say P2. Or you can say, if you want to get real quick, you can say P equals P2 equals null.
Oh, that's kind of cool.
Now the null assignment goes which way? Left to right or right to left?
Left.
Right to left. So null gets assigned to what? P2, and then P2, which is now null, gets assigned to what? Yeah, I try not to write code like that, but it works. Well, I guess for you, I try not to write code. How's that? Is that better? I'm trying not to confuse us, but it works.
That looks like a good way to organize this, so that you know these two things are connected.
And then because you've done null now, right, you can say, well, if it's not null, then you can dereference it. Don't ever dereference null. Don't ever dereference variables that are pointing to garbage, because you get either garbage or even worse, program crashes. In fact, when you dereference null, your program always crashes. Guaranteed to crash. Alright, so don't do that. Alright, you want to look at an example?
Sure.
Why not? This example, right, delete.cpp, really, if you want to review dynamic stuff, this is the one to look at. Okay, because then I'm going to create a dynamic variable and delete it. I'm going to create a dynamic array and I'm going to delete it. I'm going to create a dynamic multidimensional array and I'm going to delete it. Right? And so if you want to refresh your memory of the syntax to do either of those things, they're all going to be true. Right? Let's look at that. Under lecture 22. It's in there. So let's create some variables. Right? And star P1, star P2, star array, and I guess technically I can also do star multi-array. For 4 pointers, right? 3 of them are int star pointers, and 1 of them's an int star pointer. Can I say P1 equals new int? Does that work? Sure. Star P1 equals 5. Does that work? So if I see out, right, star P1 and what it equals, right, I'm expecting that the value is what?
5.
5. So when I run it, bring it up. Every good I got 5. Right? Now, I'm just going to call it out the line that created the dynamic thing. And if I run it, right? Everyone see how it says bash? And it says line 12, right? Well, don't think that line 12 means line 12 in your program. Okay? The big thing here to realize is this head segmentation fault, i.e., your program crashed while it was running. And it crashed while it was running because, right? And here, right? P1, which is a pointer, that points to where right now? Garbage. And so I tried to dereference that garbage spot and give it the value of 5. And the operating system says, sorry, you can't do that. All right, so what does it do to your program?
Crashes it.
Crash it, right? So just forgetting to create the dynamic thing, all of a sudden it crashes your whole program. Runtime. Yeah, when you work with pointers and dynamic stuff, runtime errors is what you normally do. Right? You thought that syntax errors were going to be not fun. Another reason why students cry in the second semester, because they work for days to get the program to compile, and they get so happy, and then it like crashes. And they got to fix all the other errors that are unlogical. It's not very fun. I don't know why you guys chose this as a profession.
Thanks for the vote of confidence.
I just was told to come to this. Yeah, that's true. You will have a job, and it is fun once you get.
Once you're not garbage at it.
Yeah, exactly. Can I say P2 equals P1? Does that work?
Yeah.
Yeah, right. And when I see out star P2 and what it equals, right? I'm expecting I also get what for output?
5.
5. Right? Is that true? Yeah. How do I create my array? I say my array, right, equals a new int square bracket 5. Right? Create my array of size what? 5. Any questions there?
Nope.
All right. What about a multi-array? Multi-array equals a new int star bracket 5. Right? Once again, multi-array is a 2-star pointer, so it has to point to a thing of what? 1 star. Okay, let's just leave it off for a second. It's all about crashing my program and stuff, right? Cannot convert int star to what? Int star star, right? Right? Because technically new int returns an int star, right? New integer returns a pointer to that spot, so it's an int star. But multi-array is a what? Int star star. And so students like to do this. Dereference it, right? Because technically that'll allow it to compile.
Oh.
But what do we get?
Oh no.
Segmentation. Why did it compile? Well, when I dereference something, it takes off a star, right? Like stars cancel out in a sense, right? So technically, when I dereference this is now an int star, right? And new int is an int star. But did that actually work? No, right? Put the star in the wrong spot. Where do we want to put it?
Int
New
star.
int star. Good with that?
Mm-hmm.
I'm still a little fuzzy on why this star is going.
Well, this star is on creation, right? That's the type that you're creating. This star would be dereferencing. Follow the arrow one spot. So since I'm creating right now, I put it on there.
Lab.
And then I have to loop, right? For int I equals 0, I less
Like
than
5
3,
days.
I plus plus. Right? My multi-array at I, which is now
Okay,
int star, right? Because I dereference, I went down a level. I just made that up.
I get it.
Oh,
I
sorry,
just made that up.
He made all this
That
up.
one should still be fine.
I knew he made it
The
up.
3 I made up is down here. create me one array with 5 rows, loop through the 5 rows, create me arrays of 3 columns.
Jeez, that's a
So
lot
I
of
get a
spots.
5 by 3 array, 15.
Because it returns an star.
The
Right?
square brackets takes the reference for you. It takes you down low. Right? Because if you think about it in an array, right? If I have my array, right, this points to here. Right? When I say P bracket 0, it knows not to put things in P, but where? It's right there. Right? So the square brackets has a star built into it. We're going to talk about this at the end of the class, which I think will help you that. So I create all my dynamic stuff. Right? Now I have to do the thing that, right, you don't like to do and my kids don't like to do, and what's that? Clean up, right?
Oh, I got it.
Maybe you like to clean up, right? I just make a blanket statement there, right? If I want to delete, right? Actually, let's do some counting. Right? I called new how many times? 1, 2, 3,
6.
4, 5, 6, 7, 8. We loop 5 times, so that's 5 news.
Oh.
6, 7, so 8 news.
Can you just do a loop that deletes the 5?
I'll do a loop that will delete the 5. Yeah. But technically I call it 8 times, but one's in a loop. Alright? So let's delete this one. How do I delete this integer? What can I delete?
P1.
Good, I can delete P1, or technically I can also delete what? P2, but not both. Right? One or the other. So I can delete P1, and then we can say P1 equals P2, which equals
No. Nailed it.
nice. How do I delete my array? Delete.
Square brackets, empty.
Okay. And then set array to what?
Null.
Well, I don't want to see it. And lastly, to create my dynamic multi-dimensional array, I do the opposite thing that I did to create it. So the first thing I'm going to do is
Loop.
I'm going to delete square bracket.
Yep.
My multi-array at what?
I.
When I'm doing that, I can delete square bracket.
Can you null at the same
My
time
multi-array. Okay.
each time in the loop, or do you
So
have to do a
okay,
null loop?
Good question. Could I null in here? Yes. But once I finish looping, what am I going to do?
You're gonna null the whole thing?
Well, I'm going to delete the array that I just nulled. Right? If you think
Okay.
about it,
So it's like an unneeded action,
right? Because I have this, and then technically I have these, right?
right?
And so you're saying, right? Let's go through the effort, and when I delete this, also set this to null, right?
But that's not gonna stay because you're
And
gonna delete
that,
the
set
other
it to null,
thing.
right? So on and so forth.
Right.
And the next thing you do is you say delete this,
Okay.
right? Which deletes what?
Oh,
thing.
that.
All the things that you just set to null. So
Okay.
there's no point.
It's like oxymoron. It's redundant.
Yeah. You're gonna delete it, so no big deal. Questions here?
You still need to null the.
Yes.
This is starting to make more sense.
What will speed it up?
Multi-array equals null.
No, actually slow it down. So it's an extra step. Run this and it works. Okay.
Oh, that's cool.
Technically, we didn't need to know all that stuff, but, you know, just had to do it. Had to
Yeah, the
null it.
order of my deletions doesn't matter. I mean, it does for the multi-array, but yeah. Yeah, I could, if I'm done with the multi-array, delete it, right? And if I'm still using the dynamic variable, keep using it.
What if they're connected though?
What?
What if they're connected?
They shouldn't be.
Okay.
They should all be, right? They're each pointing to their own new thing, right? Yeah. You gotta retake your class. Questions there? All right, you ready for something else? All right, let's talk about something else. That's still dynamic, that's still delete. But how do we do delete inside of classes, and why is that? All right, so we're gonna talk about these things called destructors. We sound a lot like what?
Constructor.
Constructors, right?
X, Y.
What do constructors do?
Oh God.
I was gonna say like a transformer.
So you're calling his ex-wife a transformer?
I actually have one. I couldn't let it go though.
What do constructors do? They what? Build something. They build your object, right? They run when your object is what? Created. Okay? A destructor is like a constructor, except it doesn't run when your object is created. It's run when your object is
Deleted.
deleted. Okay? Why do we need something to run when our object is deleted?
Because it's just memory, just being used.
We need free memory, set things to null, right? Because every call to new needs a corresponding call to
Delete and
delete. Now remember, what you do in your class, right, the outside user doesn't care about, right? The whole idea of encapsulation, right? So if you create dynamic memory in your class, it's not on the user to try to figure out, oh yeah, they created something new, I better delete it, right? Who's that on?
Us.
You, the programmer, the person that created the class. Okay? Most of the time, right, you want to use your dynamic stuff until you no longer need your object, right? You no longer need your object when it's about to be destroyed. Right? So that's why we have a destructor that says, before you destroy, I have some cleaning up. Let me clean up, and then you can destroy. Does that make sense?
So which step of the process does the destructor come just before or just after?
Just before. So, okay, how, right? How do objects get destroyed? There's two ways you can destroy an object.
Is this how like you would say you're like in a game and you use a potion and it's like in your inventory and it does that thing and then it's not in your inventory anymore?
Yeah, like I believe it. It's probably what's dynamically
It's something like that?
And dynamically not destroyed.
Okay.
So two ways to destroy an object, which is the same two ways you destroy a variable. Anyone want to guess what any of them are? Maybe you don't have to guess, maybe you know. Okay, in the program, but not technically when the program ends, but when a function ends, right? AKA when an object passes out of scope, right? Regular variables, regular objects, they get destroyed when they go out of scope, right? So that's for regular variables. Right, what about dynamic variables? When do dynamic variables get destroyed?
When we
When
delete
you
them.
destroy them, and you destroy them by calling delete on them, right?
Delete.
And so regular variables, objects, they go, right? The destructor is going to be called when they pass out of scope, right? Dynamic objects, the destructor is going to be called when you call delete on them. Does that make sense? Typically on the pointer that's pointing to do. But we're not that technical or precise. All right, I think I just said all this.
Let's hope so.
Yeah, we did all that. Okay, constructors are named after your class, right? So your class is called dummy, the constructor's name is dummy, right? Destructors are the same way, except we added tilde. I'm not going to lump myself in there. They added tilde. Whoever wrote it, they added tilde.
So it's dumb, yay.
So it's tilde dummy, right? It's not over the end, though. It's not an in yet. Right? So if your class is called dummy class, the destructor is called tilde dummy.
So it'd be yummy.
Sure. Can you like read the right in the dictionary when it has all like the symbols of how you pronounce
I can't phonetically read that
And what it
stuff.
says?
Yeah.
This is not helpful to
What do
me.
they call it? It's like
Yeah, exactly.
like the phonetic way.
Maybe I am saying this wrong. There's this weird symbols of all the letters. So there's my class declaration. Notice it's not private, it's what?
Public.
Right? Because it needs to be able to be called. And then a definition, dummy class, tilde dummy class. I know it looks ugly, but that's what you get for taking C++.
He didn't really give us an
It's like
option.
flow, it's like a little wave.
Programming and algorithms. Could have been any.
Okay, when does the destructor get called? When the object passes out of scope, or if it's dynamic when you delete it, right? So for a regular object, right, I create it here, right, it actually goes out of scope when the function ends. Right, good?
Yep.
Or, right, if it was dynamic, then we would delete it. So let me show you when it would run. And then we have one more thing to talk about, and then we'll be done. You guys seem to be liking pointers a little bit more today. Your lab's also
I don't
not
like
a
change.
two-dimensional, dynamic, multi-dimensional array, so you'll probably like your lab more today.
I don't like change.
Let's see.
22.
Let's
Delete.
Alright, I'm gonna add in a class.
That's
Alright,
how you
this
can
class
delete.
is actually the same class that we created on Tuesday. Because today's Thursday. It's not.
Wait,
it is
what?
Thursday. I'm not showing up in 2 days.
News to me.
Except that it has a destructor, and it has a destructor because if you remember in my constructor, I created a dynamic array, right? So I called what? New. And every call to new needs a corresponding call to
Delete.
delete. But we want the user to use the fill up function, the output function as many times as they want, right? I can't delete it in there. I can't delete it in my constructor because that's where I created it. I need a place to delete it, and that's in the destructor. Build an output, use the dynamic thing I created in the constructor. So really, scores, which is a pointer, and the constructor is going to point to a dynamic array. So then scores, bracket, whatever, is elements of your array. So let's refresh our memory of what that was.
Philip and output are the new tables, right? Or not?
I'll bring in the other ones too.
No, they're not mutators.
What? Because they do something with it, right?
Those would be the
This is example 2, similar to
Might be.
the other big thing you have to
You
do.
think
in your
about
lab today. Let's look at the constructor.
Constructor and
Right, constructor takes in a size, right? How many scores we're going to
It's
have,
probably a function.
right? And so I store that internally, right? Size underscore gets assigned the parameter, right? Parameter comes in, we store it into the attribute. We should be okay with that concept. Right? And then on line 37, I take scores underscore, which is an int star pointer, and I point it to a new integer of, right, the size that was given to me. Make sense? Am I good with that? All right. If you want to get technical, you probably should have some error checking because you don't want to create an array of like -5 size. Size should be at least 1.
Negative fifth dimension.
Technically, array size should be at least 1. But if you create an array of size 1, it's really like you're just creating a what?
Inner
A variable.
variable.
So,
If you create the size inside each, no matter, for instance, the actual size, even if they quit size,
they would get really good. Right? It's going to loop around, right? -5 will become a really big. And you can't really stop that. Right? Because you have to look at your. Huh?
they're making absolute value.
Now, you could do absolute value. Pretty much, you should just say you don't know what you're doing. So. You should do that.
That's fair.
Because when they run the program, the compiler will say you're trying to put an assigned int in the mode. So they should look at that warning. But they don't have to. All right, everyone good? I called new, right? Fill up loops and fills it out. Output loops and outputs it. You're probably tired of writing loops with arrays, but I feel like this program. Right? So I need some place to call delete, and I do that in the what? The destructor. The destructor is named after the class but has a tilde in front of it, right? Little scores. Right? Destructors never have parameters. So just realize they never have parameters.
Cool.
Right? What am I going to do in here? What am I going to delete? Right? Because scores was created with the word what?
New.
New. Okay, someone fix it. I did something wrong.
Bracket.
Right, because when I created new, I created it with what? With brackets, so I'm gonna delete it with brackets. And you should probably not do this, but I'm gonna see how right the destructor has been activated. That sounds a little bit better than like
Destructor.
Right, just to show you when it's gonna go. Easy enough? Questions there? All right. I still need to write main. All right, so let's write main. Main's gonna look a little bit weird because I want to put scope inside of scope. Right, so things created in curly braces exist in those what? Curly braces. Inside the object, they don't have scope. But this object I created is just a regular object. What follows normal scope. So there it is, and now I say object dot fill up. I say object dot output. Right. Here I could like see out, right, creating the object. Right. We could also, right, see out like after creating the object. Which means that I actually want to go down to my constructor and also see out, right? The constructor has been activated. Very careful, it's been activated. Gonna fill up, I'm gonna output, and then I'm gonna see out right before leaving scope. And then I'm gonna see out what? After leaving scope. Right? It says creating the object, and then it says what? Constructor's been activated, right? So I created the object. Now I'm done creating the object, and then I called fill up, right? So put some values in here. Right. And then it says before leaving scope, it says after leaving scope, and in between those two, what does it say? Constructor's been activated, right? Did I have to call the constructor?
No.
No, right? It got called automatically when the object was destroyed. Did I have to call a constructor? No, it gets called automatically when the object is created. So you won't ever say object dot tilde class, correct? Right? It gets called automatically when an object either passes out of scope, it's a regular object, or when you delete it if it's a dynamic object.
It does actually have those brackets.
Well, it would have done one thing, main stuff, but I wouldn't have been able to say after. That's my own. Questions there?
What if you wanted to destruct it like before leaving?
Then make it dynamic. Make it dynamic.
Okay.
Then when it's dynamic, then you can create and destroy whenever you want. Right? Otherwise, right? So I could say scores star object equals new scores bracket 2, right? Which means the dots change to what? You remember? Right, and now I can say delete, right, object. Would it be delete object or would it be delete square bracket object? Question.
Square bracket.
Well, did I create the object with square brackets? No. No, right? Now, internally, did it create something with square brackets? Yes, but that gets handled internally, right? We're kind of the external view, right? So I created it without square brackets with new, so I delete it without square brackets. So when I run this, it should say the destructor is activated before leaving scope. Right? Destructor has been activated. That happens when I delete the pointer to the object. And then I'm still in scope, and then I've left scope. Right? Everyone see the difference? Regular variables get destroyed when they leave scope. Dynamic variables only get destroyed when you delete them.
God,
What? Oh, what is happening?
I don't know.
So when you delete the object, what happens?
It just decided to kill itself.
Right. But then after that, then in main, it frees the object. Because what do you have, right, as we get crazy again? So that's all we do in this class. Basically, I have this object, right, that is a star pointer, right? Now it points to a dynamic object, which was made up of a size underscore, and it was made up of a what? A scores underscore. And in the constructor, we said scores underscore, if this was 2, scores underscore pointed to another array of size 2. Right? So when I say delete object, which one? No. No, this one was a care star. I think this was an int star. I think this was typed int star. I'm not, right, I have 2 layers of pointers, but this is not a multidimensional array. An object, a pointer points to an object. Inside an object, you can have as many variables of whatever type you want. So there's an int star variable in there which points to an int. Right? Yes, exactly. And so, right, the destructor is important because if I call delete object and there was no destructor, it would delete this. So what would still be hanging out? That. So when I say delete object, before it deletes the object, the destructor gets called, and the destructor said delete square bracket scores, which deletes what? This. Everyone see I was lazy? I didn't set it to null. Right? I didn't set it to null because what's the next thing that happens? This, right, goes away. I should set that. Good? Questions?
Makes sense.
You need brackets, but you should have set.
Except object got created in the square brackets, so the pointer disappears. Right. Because variables go away when you leave their scope. So there is no, down here, there is no object variable pointer because it got created in this.
That should be still set up inside brackets.
I should have theoretically just like right there after I did it, I should have said object. Just for good reference. Questions there? All right, one more topic, and then we're done with pointers. Next week, we'll do strings.
Yay.
Which are kind of like arrays, and we're great with arrays now, right? So we'll talk about that next week. All right, talk about, right, and we're going to talk about scope, right? And so if you think about it, the variables we've been creating so far, not the dynamic ones, but the regular variables, right? They have a dynamic aspect to them, right? Because they get created when a function is called, and they go away when what? Function, when it leaves scope, right?
Yep.
Which is usually when the function is, right? So they are, in a sense, dynamic as well, right? They get created while the program's running, they get deleted while the program's running, but they get created and deleted in a different way. Agreed? Mm-hmm. So instead of calling them dynamic variables, we call them automatic variables, right? Because they automatically get created and they automatically get what? Deleted. Right? You can't delete, right? Call delete on a regular variable. It doesn't work. Right? You can only delete dynamic stuff. You can only delete stuff that you created with. We call them automatic variables. That's all I want to say about that. Any questions on that?
Automatic variables.
Automatic variables, right? Right. I just want to make a distinction between dynamic variables and automatic variables. Dynamic variables get created from the what?
The new.
Where in memory though? They come from where? The heap, right? They come from the heap. We haven't talked about it, but automatic variables come from the stack. So we have a heap and a stack, and variables come from the stack. We did talk about stack last class.
I brought it up with magic.
That's right. Come back. I told you pop culture, I even magic because it's been around.
It's super old.
Okay. Something else we can do is we can actually define types or pointer types and make up a different word for that type. Like, why would I want to do that? Right? Well, let me show you the syntax and I'll talk about why. So type def is a word that allows us to basically alias types. Okay? What you're saying is int star as a type can also be referred to now as int pointer. All right? You can be silly, you could like type def doubles to now be some other word, right? Funny.
Really?
Right now all your variables will be funny X and funny Y and funny Z.
It's awesome.
Because sometimes you just get bored, so you need that extra little.
You could, if you're having doubles and you're doing like an accounting thing, you could just say this is tax.
Yeah.
Type def.
tax X, tax Y, tax Z. Anyways, it's useful though, right? That's not really useful. It's useful with pointers, and we're going to tell you why here in just a second. Does this make sense though? Basically, int pointer is now a type which is also an int star, right? So you can use int star in your program, and you can use what? Int pointer. I can to say int pointer p, and I can say int star p. Technically, they're both of type what? Int star, right? They point out. They point different. Yes. Because I said that an int star is an int pointer, right? They're the same thing.
I still like int star.
No. They're the exact same thing. They're both just int star. That's the type. The type would be int star.
I don't like this because keeping track of these things.
Yeah. Fine, exactly. But yet I say why we do this to be less confused. All right, and let's talk about why I say that.
Do you use the certain syntax specifically for automatic?
No. It's maybe worse than that, I don't know. Right? So I'm gonna ask the question, how many pointer variables and how many other variables? Okay? So give me the types of my variables. Does that sound good? It's like a game. Alright. So if I say int star p1, p2, right, how many pointers did I get?
You have one.
One, which is what? P1? And P2 is not an integer pointer, it's just a what? An integer. Right? That's easy. Right? You're like, great. Why is this confusing, right? What about now?
2.
Right? So Tim says 2 pointers, right? Because it seems like, well, int star, right, says that everything else should be int pointers, right? Except.
Well, you created an int with an int pointer basically when you write it like that.
No.
No?
You would think that that's what happened. But remember, the star floats, right? You can put it on the type or you can put it on the what? The identifier. So this star, int star p1 is like saying int space star p1.
I hate it.
It's the exact same thing. So how many pointers?
One.
One. How many regular variables?
One.
Okay?
How many annoyed students?
Right. Now how many? Yeah. Right.
Okay, now there's 2 pointers.
Now I have 2, right? There's a reason why I presented it as putting it on the identifier. Right? Because if you put it on the identifier, then we don't get confused. Right? What about now?
1 pointer.
I didn't set it yet. No pointers.
Okay, I did set it. On the last slide I said it.
You have 1 pointer now.
Alright, so I got 1 pointer, but the real answer is you have 2 pointers. Because it packaged up the int star into int pointer. So int pointer is the type for P1, which is int star, and int pointer is the type for
my
P2,
God.
which is.
That's lame.
Confusion.
Anyways, so.
Of all the things to have 2 ways to do it, why does it need to be pointer instead?
So if you don't like this idea here, then you can package it up. I don't ever package it up, I just put it on the identifier.
Awesome.
Your choice though. There will be a test on the question, or a question on the test about how many pointers and how many regulars. So just be aware.
Be aware.
Beware.
Right.
Are we good with that idea? As much as you may dislike it, that's how it works.
I guess I don't really have a choice, do I?
Everything works the same. Because this is just an alias. So it is just saying it. And down.
2 stars are no range.
2 stars would be a multidimensional array. You can also perform arithmetic on pointers, right? You can do math operations, just like you do on my integers. But you do arithmetic with addresses, not of like numbers. It's like 1 plus 1, or you take a variable and you add 1 to it. You're not adding 1 to it, you're adding 1 memory address of what it's pointing to. Right? So if integers take up 4 memory spots,
All
right,
of
when I
the-
add
all
1
the
to an integer
letters he
pointer,
could
actually
use.
moves me how far?
Chris, all the letters he could use.
Fourth consonant. Right, there we go. Here's my, well,
Oh.
take that mouse. Here is my D array.
Of all the letters he could use.
Double D's.
Alright.
Of all the letters.
I'm gonna take this one too.
You're
D
fine.
for double.
Yeah.
It's by the double D. Double stop.
That credit goes to Denzel. He was just never going to
Create an
say
array.
it.
Exactly.
So we'll just do some. I've already done this once, and no one said a single thing.
Because I didn't want to.
Well, okay.
You knew it'd be this class.
It's just after lunch, so we have like still like fuel to be awake and pay attention.
So, everyone good? D holds the memory address of D bracket 0, right?
Yes.
Everyone good there?
Mm-hmm.
So, did you know that I could say star D equals 5? Did you know I could do that?
And that it will assign the first.
It's D referencing where D is pointing to, which happens to be the first thing. And so what goes there?
5.
5. But now what I'm saying is because you can do arithmetic with memory addresses, you can actually say star D plus 1 equals 10. Right? This says wherever D is pointing to, add 1 memory address to it. So D is no longer pointing here, where's it pointing to?
Down.
Oh.
Down.
I
And then
see.
what am I going to do? Dereference it, right? So
Oh,
kind of cool.
that is amazing.
To move memory addresses.
So that's how you can put different.
So
That's how
that,
you can put different values in your array.
So you, right, you can say D, right? These two things do the exact same thing, right? This one says take D, add one memory address, dereference it, and put 10 there, right? This also says take D, add 1 memory address to it, and dereference it. And so they both actually do the same.
Oh, you don't need a star for that D bracket?
Yeah, the brackets dereference automatically, they're built in.
okay.
That's sick.
So you just put this in. You can just put this in a for loop and just.
You can write it
assign
either way, but everyone's always gonna write it at the top.
Yeah, if you do it in a for loop, it's going to be 0, 1, 2, 3, 4, 5. But this way, I could put 5, 10, 15, 20. Count by 5s.
Yeah, you could do that.
I'm actually.
All the letters he could
You
use.
can, this should make sense. You can do addition and subtraction, right? Add memory addresses, subtract memory addresses. You can't divide memory addresses or multiply memory addresses.
Oh, great.
Doesn't make sense.
How about star D minus 1?
Memory address times
There you go.
5 is nowhere, anywhere near where you just. You can't add them together. Okay. But, right, increment and decrement do just add 1, subtract 1, so you can't do that, right? So you could technically, although there's no real reason to, right? Imagine that I have some pointer and I point it here, right? I could see out, right, star P, and then I can say P plus plus, which moves it where? To the next spot, and then I can see out star P, and so on. It doesn't make sense in arrays because arrays we can just use the index to get there. When you get to other data structures, you'll do stuff like that all the time. Just addition.
What happens if you have like an int pointer star? Is that like star basically?
What do you mean int pointer star?
Like if you have like, you know how like you're going, like say your D was double star and then that was a double star. How would you, what happens if you have like int pointer star?
Int pointer to a double.
Nope.
Right. But what if you,
So it'd be double.
what if it's not a double and you're writing like int pointer star?
What are you doing with it? What are you trying to
I don't know, it's in your lab. Yeah.
I don't know.
Okay, never mind.
Don't put it in the lab. Genius.
All right, that's the line now. You just let me click the button one more time.
You mean the loop today.
It's a good thing that the
Hey, my questions have been super relevant today.
Did I ever tell you guys what my favorite part about being a teacher is? I
What?
always get new students. So.
You always get new students.
Right.
You're gonna forget about Chris
So
forever.
I might have crappy students the next semester.
And it's such a specific major though. The odds are low.
Chris is just gonna come back. It's gonna haunt you.
We can ask about question 1. What question can I ask?
Yeah, D.
Why not I do D for you? I'm only gonna do A for you.
Oh my
Right?
god.
Isn't that
One-
just a star?
1A says that, and for all of them, I already have int pointer typed as int star. So the int star is internal into int pointer. All right. So question A, when I say int star P1, star P2, P3, how many pointers did I get?
2.
2 and 1 regular variable, and I asked you for the type, right? So technically you would say int star, comma, int star, comma, int. Because Because later on you might get things that are like double stars.
So don't write pointer, just write int star. Damn.
I'll give you answers for that later, but I want you to think about it.
Okay.
No, that's not.
Create and destroy a dynamic
So the
variable.
answers to 2, 3, and 4 are in the leap.cpp, that magical file. Alright, so that's your hint for that. Let's talk about student. Okay, listen carefully. If you can do student.cpp, you're sitting really good for like the long answer part of the test. Okay, does that make sense? Right? Meaning, can you create a class? Can you create dynamic stuff in it and clean up after that dynamic stuff? I don't know the answer to that, but if you can, you're going to be doing good for the test. Okay?
I don't know the answer to that.
Let's look at student data.
Okay.
What the heck am I asking you to do?
I already have it in my thing.
I'm asking you to do stuff.
Oh, we have to define the.
All right, so the student
Stuff.
class, right, takes in a name and a number of classes. Okay? It's attached to the bottom of this initial file. Right? It's just one file, right? Last class you had 3 files, today just one. Constructor, destructor, right, accessor, commutators, that kind of stuff. Most of the time, students don't realize it, but the green stuff, I don't know if it's green for you, that normally tells you what to do. So if you read it, then
It's usually
you
above.
don't have to ask me. Right? It's like in the constructor where I say, what? Sets name underscore to its parameters, sets num classes to its parameters, and creates a dynamic string array, right, and stores in what? Class list underscore. So you'll notice that in your class you have 3 variables, 3 attributes really. Name underscore, which is a string, right? Num classes underscore, which is an int, and then a string star which will point to a dynamic array. How big is that dynamic array going to be?
Whatever the parameter is.
However many this input.
The parameter,
Whatever
right?
num classes is, right? Because your class list should store as many classes as the number of classes that you have. Does that make sense? So num classes is size, right, for your array. Right, I wrote the code in main to create you and change you and set up your classes and output them, right? So your goal is to write all this. Sound good? Can we handle that?
Mm-hmm.
Question? Yes, you're gonna write the function definition. So
nobody
I'm giving
got
you
time
the
for
above
that.
main and main, you're gonna write double.
True, actually.
Okay, today is your last, right, lab on pointers, right? Next week we'll do strings and C strings. And the following week we'll do review on Tuesday and a test on.
And then we have to turn in our coding
You
assignment.
guys turn your code assignment.
Yeah.
Oh, geez.
And then we're
come
done.
back the following week and we can hang out, maybe eat some food, play each other's games, grade them.
Grade them.
End the semester on a good note. The semester will end on a good note if you've done your game. If you show up and you haven't done your game, the semester's going to end on time.
I mean, I did 4 of the
Good.
5
Questions?
assignments.
All right.
I did about
That's all I got.
95%.
You don't get yourself down, or?
So these are all
I'll put some of the
star.
answers to the PDF here in a minute.
Yes,
That way you don't have to do your work.
you are correct. What is my name? That's a good question.
It's the size of the
Antonius? He's pretty good.
Because you're going less
He's
than
been having a rough time.
not helping.
It's crazy. There's a kid in here that got into the tournament from the 5-year qualifier. He was like the chip lead and then second chip lead for a long time too. He's like a nobody, like just qualified. Because it's poker stars, so he did some online qualifier and actually qualified and is actually doing really well. This is no. He's got a hat on. I think, yeah. Before the final table, he took someone out because he went all in for unpaired Jackson and won it and doubled up and became second chip lead. River. Yeah, here's the thing though, Zhang just won because he had a pair of kings. Pocket queens didn't do anything. That's what I'm saying. That's how he's been. That's what he's had to deal with for the last like 3 days I've seen. That kid to the left, to his right. That's the kid that's like just qualified. The 5-year is pretty good tournament. He's just killing it. Yeah, he's killing it. That's right. Yeah, that's him. Number 3, Georgie. Peters is like the white American dude in the blue shirt over there. I think he's the only American left. Well, Kevin Hart was in day 1. I think he made it to day 2. I don't know. Sheep. Oh, really? Because this is final table, they're trying to get to the final 6, and then they'll go to that tomorrow. I guess Fernandez, big Mexican dude with the throat beard and the ponytail thing, he might also have been a qualifier, but from a different, I don't know. When they were talking about it and they mentioned how well he was doing, when they reset for the final table and brought everyone, they were doing tables of 8. Yeah. Right. But the final table then being 9. So it was the first time players the entire tournament. This is like day 5. I've played with 9 at the table. So they finally get to 2 and 3 with pots. He's been one of the chip leads. That's Shemin.
Today, just right click the multi-dimensional.
Write the code to create a dynamic variable. Whoops. Yeah, she's in the game against Peters. It's got pair of jacks. He's blocking straight as well. Nothing to worry about. And it's already on the turn, so he's trying to get value from the river.
Say Tony is really the champion? Is that not paying attention?
Someone's gone.
Yeah.
I knew it!
Remember, if you put the star on the end, it's so close to the
Wait, they're not all star star because they all start with one star because the end pointer?
On B?
D.
D? But this one had another star on it.
Yeah.
Right? Do they not?
So end pointers star star, and then the rest are star. Okay, yeah, that's what okay, I just misread it. And E's kind of like the reverse.
Right. Because the end pointer is an int star, so when you add another star, then you get two.
Right.
Right. You don't have that because it's an int star. So that you don't add more, you don't add size and stuff. Yeah, but that's just me saying that. When we call it insert, I insert one.
So you would just call new int? Is that what you would do?
Just going on point.
To create a new dynamic variable?
Need help, Chris?
So it would just be int star p1 equals new int. Oh, I'm pretty sure.
No.
Yeah. That or there's no star.
Which one is that? 2?
I think it was destroy.
No, you have to initialize the pointer and then assign the pointer to new int.
That's what I just did. Int.
No, but then you have to say p1 equals new int.
I did.
No, you said star p1 equals new int. So you have to initialize the pointer first, and then you put p1 equals new int. Yeah.
That or back? Or I have it back.
Well, you gotta delete the int in front of p1 though. That
Right,
one.
right,
Yeah,
right.
and that's it. And now, to delete it, you just delete p1, because then it's just deleting the integer that you've created that it's pointing to. That's it. Like cheese and crackers. Because the way you did it when you initialized it and then set it equal to new int, it didn't know where it was.
Mm-hmm.
It was like, what? I'm having fun with the member functions.
When you did your subfunction for the output first, did you put string in front of it? Yeah, I think we did. Like a compile, I get this,
Oh.
It's a huge op.
Watching poker.
Yeah, but I think he did it.
9,190,000 dollars.
That's just chips. It's tournaments. That's just chips.
He's got 2 pair right now.
I honestly saw
He's gonna win. Why would that guy go all the way to 10? Is he playing that card?
Well, it's a decent spread for what the board has.
No, but he's literally betting on the fact that he has the highest card. He's hoping that no one else has a
poker, dude.
I know.
He's counting on the spread.
I mean, he's got a
So
pair.
when the turn had a 7 of hearts, he was banking that he had a flush and was gonna scare people out.
Yeah.
Does that make sense?
Well, there's only 2 hearts on the table, so there's no way he could have a flush.
Yeah, but they don't know that he doesn't have 2 there.
Yeah, but even if those were 2 hearts, he still wouldn't have a flush. That's a diamond.
Yeah, 2 hearts. The river.
The river was. Oh yeah.
You have to understand they don't just start knowing the river.
I know. I
He probably three bet
I
on
didn't
the
know you were
big
talking about that card not showing up yet. Yeah, I guess
Well, that was implied because of the poker. You know the river comes last.
Yeah, I know that.
So he's in it for the win because he's bluffing a flush.
Well, he's fucked.
It wasn't a terrible play.
No.
Because you know he's blocking the straights and you know he's blocking, you know, everything there. So like, it was an educated bluff. Just by looking at it, I didn't hear it. Yeah.
What's the pot?
I didn't see it. It didn't show. If you were listening.
There it is.
Oh, there it is.
2,800,000. Oh yeah, he won that one. That's why he got up to 9. Oh, that's insane, dude. Side pots of 1.7 million. That's just a side pot. That guy who got the pair of 8s got the side pot probably.
Oh, hi. I was going to ask about 21.
Sets name underscore to his parameter. It's not too hard. It's name underscore to his name.
So you shouldn't be adding anything to the die. It's always like
This one,
What?
you're just gonna work his name, and then you do that. So like, all right, I can do that.
Yeah.
I got this.
And then you realize 3 hours later. It
Oh, you know the output function requires a for loop, right?
Yeah.
Yeah.
What I don't understand is the accessors of string names.
I'm not there yet. I'm on 4.
Can you repeat that question?
The accessor function, that's string name or whatever. I don't know how to write it I don't know how to write the actual function. definition.
Student : string name, and then delete the semicolon and put curlies.
I got a name when it runs. Instead of problems.
Maybe you just don't add. Maybe it's you don't initialize the access, right?
Usually, if it has.
Oh wait, no, it needs to be void. It needs to be void because it's not.
No, it's an accessor.
It might have to be void because other than that, it should work.
It's a type string, and usually you put the type before, but I've
Maybe.
never wrote a string function, and it doesn't.
You might, yeah. If you might have to put string. Because shouldn't all functions have at least a return type?
It's a mutator, so it should allow the program to shape how it works. So I think it does.
What do we get?
It'll just set the name to detail.
Okay, so.
Is it combining it all?
No, I tried.
That's eating, what are the other ones?
They're not sparkly, some place.
Did it.
right? That's how I feel sometimes.
Scroll down.
Dynamic string array. Okay. That's not too hard.
So, the accessor function for string names, I'm just not really sure, like, it doesn't go out in front, does it?
I know it does.
It does?
Yeah.
Okay, and then.
That's the return type. So then you just.
Yeah, that's what I thought.
But then do you put string?
No.
No, it's just how I have it?
Yeah, I got it.
Okay, and then this, so that was fine, but like when I got rid of it, so.
No, you didn't.
That's right. And is that good?
Not named though, but classes. So you want to put a size like an integer.
Okay. So non-class.
Yeah. The name is a string, right? Because you're a student. So a student, like think about it. Attributes-wise, a student has a name, and now they're also having how many classes they're taking, and then they have an array with the names of all the classes.
Okay.
Oh, Luke.
And then but what I was doing when I got this is I got that one 12.
And that's probably just because so it compiled. As you say, John Doe has blank classes,
Yeah.
right?
So I didn't get like the this is just like because I haven't written all of these out yet. Okay.
So Luke, for the constructor, does it matter what the name of the pointer is?
Well, yeah, because we've named it in the class in the H part, like in the top. So.
Okay, I'll just look.
No,
Class 2 through 3, I feel like maybe I'm a little off on one. 2 through 4.
Should just be like int star p equals new int, delete p.
So it's right here in the private, right?
Int star a equals new int bracket some size, delete square bracket a, and then the one part.
4 is probably the one I have the most problem with, I think. I think that these are okay.
Yeah, 4's not so good.
4 is wrong,
Yeah,
I
there's
think.
more to it.
Am I missing a piece like in between here?
Yeah, because this creates a pointer. Now the pointer points to a new integer array of pointers, and then we point each of those pointers to.
So this needs a bracket, right?
No, that's just that. Let's go into.
Or you should have this one up, but I don't really see
The
anything
delete,
in
not
it.
destructor. Delete. You notice in here, I create your pointer. I create the array. If you scroll down a little bit, I create the dynamic array. So this is what you're looking for, right?
Oh,
Okay. So it deletes farther down.
Yep. Okay.
Yeah, because I think that's the equivalent of the fill-up one. I'm pretty sure.
I don't think it's.
Yeah.
You're all, are you set up with April to do that yet, or are you still like? Possibly, yeah. I think for sure it'll be next question. Next question will be.
That might be right. Maybe.
How did you do number 4? You're not,
Oh, number
you're
4? I can go back.
You're limited 20 hours in total. You do that with us.
Right, to initialize the multi-array, which is has to have 2 stars because it has to make a new integer that's type of int star. And then in order to write to all the different spots, you have to make another. You have to use a for loop to write to all the different spots in this array. So right now it's 25 spaces big because it didn't specify how big this had to be. So I just set it equal to I.
right. New. Let's just give it a value.
8, whatever.
Okay,
Yes.
and that's where you did for. So I was actually really close. Okay.
Yeah, but you need a star between int and the brackets in that in that step. No, not there.
Are you sure?
Mm-hmm. It needs to be between the brackets and int.
I don't see it. Oh, okay.
Yeah. And then now you make a for loop that writes to every spot in that array, but it doesn't. They didn't specify the size, so I just set it equal to I, and then it's 5 by 5 is 25. Whatever works. And then you have to go through 2 steps to delete it.
Yeah. So that's done. And then to put it down.
I'll be right back. Yeah, ask Luke a question. Luke, I have a question. So you didn't exactly specify the size of the array and the constructor, so I just said no clauses. Okay.
Yeah, because that's the only thing that has a size.
Yeah, because I looked in int main and it accepted a 4, so I just put it in there.
Did you put the null part down and stuff too?
I didn't do that. I mean, I could do that, but no. Okay, the destructor is supposed to set something to 0 somewhere. What does it say? Oh, I just have to delete it. Okay. Watching some poker.
Yeah, I was seeing where they were in the front of the table.
Oh, is this on right now?
Mm-hmm.
It's fine. Okay, I don't know where I am now. I got lost. Shit.
Yeah, it'll evaluate the inside and it'll give the assignment.
Interesting.
Oh, why? Just my Well, I mean, any graph. No, we'll have no, so it'll be more like, you have no separate items, so you have directed graphs where yeah, I don't know why you're gonna like bar that out of like a line graph. Kind of like what you're doing with your path. You're always path.
This where you would just do delete brackets, class list
Where are you at?
for the destructor. Delete bracket.
These are you can get a little access, but
Yeah. That would be correct.
so pretty funny. Not every time it will, it's a self-balancing type tree, so it will at times. You kind of mark things certain ways, and then it will at times. I mean, you're not physically doing it, right? You're just calculating. Right, exactly. It's just, right, something in some random memory location is pointing to some other thing in some other random memory.
So this is an accessor, so this is doing what? This is the for loop, right?
No. That's just made so you can access where that information is. So the accessors in the mutator don't need any. Well, they need to be defined, but they don't need anything in the function. That's what I did.
So you're just returning string. You're just returning name.
Yeah.
That's it.
I think so.
Is that what you did?
I didn't do anything for those yet. I'm just assuming what you're saying is right.
But they don't physically need to provide so
This one doesn't matter.
Two.
Oh, there's two on there.
Oh no, this is recap.
Alright, let's see if this will run. Nope. Look at all those errors. Oh God. Oh. Put a star in
Dang,
front of it.
look. Only one thing wrong. That it saw. In 98, the last thing I wrote.
What'd you do for student and where's your constructor at? Oh, you didn't set the. Hold on a second. I'll fix this.
Yeah, those are recaps. They must
Solved a
have
few
break.
problems.
Because I think every half hour at the final table, the blinds go up. So they give them a break while they reset. And I think they rearrange who sits where so that the advantage is for different people. It's like a different. Because like you don't want to be to the you don't want to be to the left of the chip lead the entire night. You know what I mean? Like that sucks. Because you're under the gun, you have the button, you're the small, you know, like you have to act on every chip. They're big blind before you know, like you get no action because they bully you out of everything just by sheer equity. Their ICM. I like Daniel though; he's cool. He was in this tournament, I think, but he got out early. Pretty much everyone that was on the table with Kevin Hart went out because they were distracted by having so much fun playing with Kevin Hart.
We got 2 minutes here.
Daniel Negro, or whatever, he's Canadian, yeah. Negronin.
Rip. Did you forget the parentheses?
What if it's name underscore that you return?
Eventually, your GitHub and my GitHub stuff will all link. Yeah, and there's a way to transfer it from, so right now it's like in my GitHub organization, there's a way to transfer it to keyboard. Ideally, the only thing I request is that's keep posting. So GitHub, once you sign up with your student email, they'll give you private details.
Oh, you know what? Maybe this is why it's wrong. Maybe I need to cut this, put that here. Put string in this. Oh, sick, dude. I got something. Hell yeah.
Oh no, segmentation fault.
Hey, I was getting something wrong before.
So I wrote them all. These are like this is the only one I'm not really sure on. Do I just set the default to 0?
No. Mutator always takes the parameter and stores it into the attribute.
Okay.
So just like you did on line 75. Exact same thing.
75. My 75 is going to be different.
So don't fix that. Just name underscore. Yeah, I know. I didn't tell you what to do because now that's just what mutators do. Well, because the constructor does it on creation, the mutator allows you to change it in the end.
Okay.
So like because on creation I set the name to John, right? So then later on in the code I wanted to change it to Jane. I can't call it constructor.
Changing John to Jane comes up after that.
That's fine.
See, I'm still missing for.
Try typing it. Oh, it's a part as that.
It's like a single person.
CN and yeah, right. Isn't oh you said name underscore, not
Yeah.
class list. That's fine. Next week we're gonna learn that strings are arrays behind the scenes, so which is flex.
Okay.
What's the class list?
What is it for the loop? Is it I less than class list? Or what is the
Num classes. Yeah.
num classes underscore or just num
Just num underscore classes. Yeah.
Kinda have some questions though.
Let's run this and see if it fucks up.
So what am I doing in this loop?
Oh, I have billion errors. Holy crap. Class list was not declared in this scope. Did you forget the parentheses? Set up classes. It's all in setup classes right now.
The name of the function is name.
Hey, what are you changing in your for loop for your student?
Which one?
For setup? Well, I've only written one for loop so far, so.
You're gonna have two. So for the setup classes or
Yeah.
the setup classes,
What's the other one you have a loop in?
the output class. Okay.
I just have to put another underscore.
Yeah, so
But you lost, right?
I don't
I think
have
was a
that
void,
one.
right? You lost.
I may not have copied that one down on accident. Oh, I'm just not there yet. I'm still on the student setup classes.
It compiles even without its stuff.
Yeah.
Really?
Mm-hmm. It has 0 classes, changing John to Jane, and then I have a bash line, blah, 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 blah.
Okay.
So now that I'm writing this for loop, I just didn't know. So, okay, what am I incrementing with
What
I?
else goes?
So I have
all the
I
functions, anything that has parens at the end of the name.
semicolon, I
Okay, so like a
plus the
constructor.
number of classes.
Right, I have that, but what inside the for loop, what is it that I'm right? That's what I'm,
I have
oh, okay.
CL, enter the names of your
What
classes.
I don't understand what it is exactly that I'm incrementing.
Like what I'm actually. That's the index. The index of your array. And your array is called class list.
I did it. It worked.
So it's class list.
It works. I just had to add that extra
it's
underscore
class
because there were functions
list
named num underscore classes, and I had to put an extra underscore because I just returned that in the accessor. The frick! And now I can put in the names of the classes and it works.
Oh, okay, that makes sense now. Okay. Okay.
I did it.
You create an array of a size, and now you're looping through and filling it up with the actual class name.
It's just that
Right.
anticipation
Like
when you
that.
click run and you're waiting for it to compile. You're just like, is it gonna work?
And you should have
Mine was
CSCI.
like, because I
You
would
always
type
have
in
CSCI.
like art, and then so
Like
it
the
would say my
prompt
classes
yeah.
were A, comma,
Should I do that before the loop?
and it's because I was using the name
So it's
underscore
not like-
my array.
Yeah.
Which somehow worked,
So you're gonna do before
but
you write CL.
It wasn't the right way.
Enter
Yeah.
your.
I'm gonna see if my code works.
Right.
Let's try this. My input for class 1. I don't know. Whoa, again. Please input a name for class number 2 and 3. I think it's broken. Okay.
4 classes.
Segmentation fault. Oh no. It's not good. Oh, I know what I did wrong, but it's not good.
Is it num classes underscore in the loop?
Yeah, any of
Yep.
any of the ones where you don't define it again, like num classes underscore equals num classes,
Right.
you always have to use this underscore.
Right. So that's what you're incrementing in your loop is num underscore classes underscore.
I think so. That sounds right. Yeah, num underscore classes underscore. Yeah, I learned that in the assignment 4, like the hard way. Like, everything was right underscore. I just didn't put that as an underscore at the end. You know? So I was like, oh, I defined it over there.
God damn.
But every single time it works.
So enter your number of classes. Blah, blah, blah.
Segmentation
Okay.
fault.
So in this one,
I'm going over the cliff is what's happening. Good enough.
oops. And then this is where I would just go class list I. Whoa.
Oh no.